Yes, good morning to everyone. Okay, we'll go with today's session. So, what about the content we have discussed in the previous session? Working off port 0, port 2, and port 3 we have discussed. Okay, then we have introduced about the timer operation of 8051. Correct? Yes? Okay, so now we are going to continue that. So, 8051 microcontroller has two independent timer block counter. Can you name the timers? What are the two timers we are having in 8051? Yes. Kindly type it in the chat. Yes, timer 0, timer 1. Very good. Okay, so it is termed as timer bar counter. That means it can be configured either as a timer or counter. That's why we are saying it as timer bar counter. So both are binary up counter, okay, and it is having a 16-bit register to hold the count value. Fine. So what are the two registers we are going to use as a 16-bit register? For timer 0, we are having two registers, TH0, TL0. So combinedly, it is going to have a 16-bit value. To load a 16-bit value, you have to load the lower byte in TL0 and higher byte in TH0. Fine. Similarly, for timer 1, so TH0 or TH1 is the higher byte register, and TL0 and TL1 are the lower byte of the registers. Fine. So this structure will give you a clear idea. So to put a count value in timer 1, you have to load TH1 and TL1. So the TH1 contains the upper 8-bit, TL1 contains the lower 8-bit. Fine. Similarly for timer bar counter 0. Fine. So in the previous class, we are speaking about the timer operation. Okay. So timer mention it is also going to do the counting operation. But what it is going to count? What it is going to count? It is going to count the clock pulse, internal clock pulse generated. Fine. See, we are providing a clock input to our microcontroller. Fine. That clock input is given through a crystal oscillator. Correct. So the oscillator frequency is getting divided by 12. So that is given as the input pulse to your timer. Fine. What about the count present in the timer register on each clock getting to the timer mod? Fine. See, already I have told you why it is divided by 12. Can you people type it in the chat? Why it is divided by 12? Yes. 12 clock cycle equal to what? Yes, very good. 12 clock pulse is equal to 1 machine cycle in the case of 8051 microcontroller. Fine. See, classroom 1 la mattumda respond pannum. Classroom 2 la yarume respond pannadilla. Fine. Okay. Fine. So for every 1 machine cycle, we will be going to get 1 clock pulse to this timer module. Fine. So here we are mentioning it as X. X denotes either it can be timer 0 or timer 1. Both is going to have a same operation. Fine. But both are going to be independent. Fine. Is it clear to everyone? Fine. See, timer it is going to count the internally generated clock pulse. Whether this clock pulse it is going to be changed, whether it is a fixed thing or it is going to change. But I get 12 megahertz input kudutana, inge 1 megahertz clock input kedaikum timer. Correct? Whether it is going to change at any point of time, unless you change the crystal value, whether it will change or remain same. Yes, it is not going to be changed. Correct? That means it is counting the fixed pulse. Correct? Fixed frequency pulse. That means for every 1 microsecond, this timer it is going to increment by 1. Its count value. As it is up counter, it is going to increment by 1. The count value of the timer gets incremented by 1 for every 1 machine cycle. Fine. Then we are saying timer overflow. What about the maximum count value you can have? What about the maximum count value you can have? We are having a 16-bit register. So what about the count value you can put a maximum? Kindly type it in the chat. You can type it in hexadecimal. Yes, very good. FFFFH. Fine. After it reaches the maximum value, if one more pulse is coming to the timer, what about the condition now? maximum count தாண்டி நம்ம ஒரு pulse கொடுத்தோம்னா என்ன ஆகும்? It is getting to the minimal value. That means from f of h, it is going to change to 000h. At that point of time, it is going to generate an interrupt. That we call it as timer overflow interrupt. As this interrupt is generated by the timer overflow, this we call it as timer overflow interrupt. Fine. So we are having two timer overflow interrupt, one for timer 0, the another one for timer 1. Fine. So these are the two internally generated interrupts. Fine. Whenever the timer gets overflow. Fine. Next. What about a counter? The render diagram compare panni paakalama. Here Intel 8051. This is an IC. Within that IC we are having the oscillator circuit and clock divider circuit and the timer module. Everything. Fine. What about in this diagram? What you are inferring from this diagram? Here also we are going to give pulse to your timer bar counter. But from where it is getting into? Internal or external? Very good. It is from the external sensor. The sensor, for what purpose we are going to use? Whether a person enter into the room or not. Whether the temperature get, it won't be a good thing. See, wherever you need some counting operation, you have to detect the event, whether the event happened or not. Fine. The best example what we can say is a visitor counter or a cash counting machine. Fine. Whenever an object crosses, the sensor should produce a pulse. Correct. So here, in this case, when an event is occurred, say for example, somebody crossed here. Okay. Fine. That event happened. So at that time, you will be getting the signal from 1 to 0. Fine. So active low sensor you must be using in the case of counting operation. That means whenever a person is detected, the signal at the pin TX. Here TX stands for what? T0 or T1. That means the externally given signal, which is called as counter input. Fine. Timer அப்படின்னு சொன்னா நமக்கு என்ன பண்ண தேவையில்லை, வெளியில இருந்து ஒரு பல்ஸ் கொடுக்கணும் தேவையில்லை. No need of external pulse. Simply it is going to count the internally generating pulse. Fine. Whether in the case of counter, there must be an external input to the counter. Fine. So for this purpose, we are using the port 3 pins. I hope you people know it very well. Yes. 2 pins of port 3. It is used as counter input 0 and counter input 1. Fine. When you are configuring this timer bar counter as counter, the incrementing operation depends on the count input. When the count will get increment? When the count will get increment? When the signal is changing from 1 to 0. Yes, very good. When the event occurs, at this pin, the signal level must change from 1 logic to 0 logic. This we call it as negative edge or falling edge. Fine. Then one more important thing you have to understand, if an event occurrence 1 to 0 transition is detected in a machine cycle, at that machine cycle itself, it is not going to increment. Fine. It will check in the next machine cycle whether the signal again got high or not. If it still maintains 0, what it means? And the event occur mudiyilla. Correct? When the signal changes from 1 to 0, the event start occur. That means an obstacle is present near the sensor. Till the obstacle get moved, the counting operation won't start. Fine? That means what? Once it comes from 1 to 0, in the next machine cycle, it has to again go to high. Yes? So that indicates an event is completed. Once the event get completed, the count value get incremented by 1. Fine. Here, the counting frequency is given by FOC by 24. That means this must be the minimum frequency of operation of the counting. Fine. If a person entering into the room or an object is crossing through the sensor, if its timing is 24 by FOC, less than 24 by FOC, your system cannot able to detect the event. I hope you people can understand. என்ன ஸ்பீட்ல இது கவுண்ட் பண்ணதோ அதை விட வேகமா ஒருத்தவங்க கிராஸ் பண்ணா என்ன ஆகும்? An improper value will be getting. Fine. So that's what this thing is mentioned. Fine. So kindly go through this diagram. You can understand. Whenever an event occurred, 1 to 0 transition occurred, fine, it sends an event. At the next mission cycle, it will check whether the event is completed or not. Fine. If that happened, it is sensed as one time the event is occurred. Fine. That means one mission cycle to detect an event. Fine. The another mission cycle to increment the count value. That means it requires 2 mission cycle minimum per count. That means this is the maximum counting operation can done by your 8051 timer. Sorry, counter. Fine. So FOC by 24 is the operating frequency of counter. The minimum of the maximum operating frequency of counter. Fine. So this thing you have to understand. Now design பண்ணக்கூடிய system பொறுத்தவரைக்கும் என்னோட object moving வந்து நான் count பண்ண போறேன் அப்படினா the time taken for the object to cross through your sensor must be greater than 24 by FOC. Here FOC by 24 is the frequency. You need time, you have to take the reciprocal of it. That means 24 by FOC. Fine. Then here also when the count changes from the maximum value to minimum value, it produces an interrupt. Here also we are going to say timer overflow interrupt. Fine. See, the input to your timer, it is getting changed, that's all. But the operation of the timer or counter, it is going to remain same. Are you people understand what I am saying? Timer no sonalum, counter no sonalum. In both cases, it is going to count the pulse. How many times the pulse occurred? Correct? But in the case of timer, we are measuring the count of the known frequency. என்ன frequency நான் input கொடுக்கிறேன்றது எனக்கு தெரியும். But in the case of counting, we don't know when the event is going to occur. At any point of time when the event occurred, the count is getting incremented by 1. That's it. Fine. Is it clear to everyone? Can you say timer operation means what it is going to count? When I say timer operation, what it is going to count? A known internally generated clock pulse. Fine. Okay. When I say it is a counter, what it is going to count? Yes. Yes. It is going to count the external input, that is from the counter input. Fine. That's all. So this is the case what I have told. So this is the 16-bit register. 111. All bits are 1. This is the maximum value. When the count changes from this to 0, this we call it as timer overflow input. This is the meaning for timer overflow input. Okay, fine. Okay. Now, what are the special function registers associated with the programming of timer bar counter? That we have to know. Fine. Okay. The very first thing what we have to know is these are all the SFRs we are going to use to program the timer bar counter of 8051. Fine. Here the byte address are mentioned. Okay, but anyway we can use the name of the SFR when writing the programs. Fine. Okay, idhila edala bit addressable path solla mudiyuma? Out of this 6 register, which of the registers are bit addressable? Yes, can you people say? Yes, Tcon. Why it is termed as bit addressable? What about its address? Its address ends with 8. Okay, if an SFR address ends with 8 or 0, fine. I am speaking about the lower nipple. Fine. If it ends with, if the lower digit of the address ends with 8 or 0, then it is going to be a bit addressable SFR. Fine. So what about the purpose of Tmod? In the case of timer bar counter, it can be operated in 4 modes of operation. Fine. It can be operated in 4 modes of operation. That is the very first thing. Then it can be either operated as timer or counter. Yes, that is the another thing. These things and all can be configured using the Tmod register. Fine. Timer mode selection register. So using this particular register only, we can choose the mode of operation and whether we are going to configure it as timer or counter. Fine. That is the meaning for Tmod. Fine. The next register Tcon is used to control the operation. First one is used to select the mode of operation of timer bar counter. The second one, for what purpose we are using? To control the timer or counter operation. Fine. Already we have told this 4 register. Yes, TH0, TL0. Combined with this 2, it is going to hold the count value of timer bar counter 0. Then TH1 and TL1. These 2 things, it is combinedly, it is going to be used for holding the count value of timer 1. Fine. I hope it is clear to everyone. See, in the register order purpose, yes, using Tmod register, we can configure the mode of operation of timer bar counter. Okay, using Tcon register, we can able to control the operation of timer bar counter. Another timer and start stop control, we can done with the help of Tcon register. Yes, is it clear now? Shall I proceed? Yes, fine. Now we will get into the Tmod register. Okay, so Tmod register, it is for timer bar counter mode configuration register. Fine. So it is going to have a word format like your control word format in 8255. So 8255 control word format paatholingla. Similarly here, this register, it is going to have a word format. Fine. Also you can relate with PSW register of 8051. PSW being first bit carry, add auxiliary carry. Fine. So like that, here we will be going to have a word format. So this is the word format for Tmod register. Fine. Okay, this Tmod register is divided into 2 portions. The lower 4 bits are used to configure the timer bar counter 0. The upper 4 bits, it is used for configuring the timer bar counter 1. Fine. So Tmod abin sonnona the rendu pirikrom. The lower 4 bit for timer 0, the upper 4 bit for timer 1. Fine. Okay. Shall we proceed? Yes. Yes, fine. The very first bit, that means either, see here also in the 4 bit enna purpose, so the same purpose it is going to do, but this one is for timer 0 and this one is for timer 1. That's why we are saying independent, 2 independent timer bar counter. Fine. Timer 0 na enna pannalam timer agum, I mean timer 1 na counter agum use panikka mudiyum. Is it clear? That's why we are saying it is independent. So the timer na configure panna, idhiyum timer da configure panna avashyam kediyadu. Fine. Fine. First input, fine, MSB bit, gate control. Either this bit or this bit, it is going to be for timer bar counter 1. It is going to be for timer bar counter 0. Fine. Gate control. The gate control enna purpose kabin pathina, through hardware I can able to stop the timer bar counter or start the timer bar counter. I mean I can enable or disable the counting operation using this control input. Fine. If I am saying it can be done by hardware, how I can done it? How I can done it? When the gate bit now 1 have been set panana, externally I am going to have a control input. And the control input I usually I can stop or start the timer bar counter. Fine. See, like your play button. Okay. Play button nama click panna go play agum. Again if you click it, it will be getting turned off. But inge different if I am saying gate bit is 1, there must be an external gate control. There must be an external gate control which must be enabled to run the timer. Fine. So adukku endha pin use panna porom appdin pathina INT 0 bar and INT 1 bar. Fine. That means if I gate control enable panita, this must be the condition to run the timer. Okay, I will say you what is TRX later. Okay, as of now INT 0 bar, INT 1 bar, this particular pin we are going to enable the timer operation. Fine. Now timer la configure pannite gate control enable pannirken appadina, if the external pin INT 0 bar or INT 1 bar na 0 pannirna appadina meaning enna, the operation is not enabled. Fine. So this and all we can discuss later with the diagram so that you can understand. Fine. If this bit is reset, the external gate control is not needed. Fine. இந்த bit நான் 1 பண்ண அப்படின்னா external control நமக்கு இருக்க போகுது. So using that input, I can stop or start the timer operation, enable or disable the timer operation. Fine. On seeing the second bit, you people can say C/T bar. Can you guess? C stands for what? T stands for what? It can be used as either timer bar counter. Yes, C stands for counter and T stands for timer. Very good. Okay, that means if C/T bar is set na meaning enna 1. Irundhuchina it is going to function as counter. Yes, if it is reset, it is going to work as a timer. Is it clear to everyone? Is it clear to everyone? Timer configure panna poroma, counter configure panna poroma. That can be decided using this bit. Fine. First bit edhukku use pannom. Additionally, external namakku oru control venuna, you have to enable this bit. Otherwise, you can disable this bit. Fine. If you enable gate control, you must enable the external control. Then only the timer operation is going to work. Otherwise, the timer is not going to function. Fine. Then M1, M0, these 2 bits, it is used for mode selection bit. Why we are having 2 bits? Using 2 bits, how many combinations we can have? Using 2 bits, how many possible combinations we can have? Yes, very good. That means 4 modes of operation are there. Fine. The mode of operation can be chosen using this 2 bit, M1 and M0. Whatever I have told for timer bar counter 1 bit, it is same applicable for timer bar counter 0 bit also. So here also we have gate control. Here also we can have the control to configure whether it should be a timer or counter. Here also we can choose the mode of operation. Fine. So whatever the thing I have told here, this is applicable to timer bar counter 0 also. Fine. We will see what are the different modes of operation. We will see now. If both bits are 0, 0, then mode 0 operation. Fine. If bit M1 is 1 and M0 is 0, I think here one mistake is there. Fine. 0, 1. Correct it. Wait a minute. Slide number 9. So this must be 0 and this must be 1. Sorry. Yes. Okay. If it is 0, 0, that indicates mode 0. 0, 1 means mode 1. 1, 0 means mode 2. And 1, 1 means mode 3. Fine. Based upon the mode of operation you are going to configure, this bits must be chosen. Okay. If I choose 0, 0, what mean by mode 0 bin patana? 13-bit timer bar count. Even though we are having 16-bit count register, okay, in mode 0 it is going to operate as 13-bit timer bar counter. Fine. How 13-bit bin patamna? It is going to work as a 8-bit timer bar counter with 5-bit prescaler. I will explain in detail in later slide. Fine. As of now, what we have to know, mode 0 operation means it is going to have a 13-bit. Fine. 13-bit timer bar counter, or you can say 8-bit timer bar counter with 5-bit prescaler. That's the meaning for that. Okay. Then regarding mode 1, it is 16-bit timer bar counter. That means the entire 16-bit we are going to use it for count purpose. Fine. Count register. Fine. So how the 16-bit is formed? TH and TL combine it together and are cascaded. No prescaler here. Here we won't be having any prescaler. That means the entire 16-bit, if it changes from 1, 1, 1, 1, that means all ones, FFH to 0, 0, 0, H, you will be going to have a timer overflow. Fine. Coming to mode 2, this we call it as 8-bit auto reload timer bar counter. What do you mean by auto reload? Whenever timer overflow occurs, whenever the timer overflow occurs, the initial count what we have put, it is getting again and again reloaded. That's why it is called as 8-bit auto reload timer bar counter. Appadina enna panna porom? One 8-bit register THX is used to hold the count value to be reloaded, and TLX is going to work as a timer. Fine. So TH, TL, rendu parts sono correct ingla? THX, it is going to be used to hold count value, and TL0, it is TL0 or TL1, it is going to work as a timer bar counter register. Fine. So this is the most commonly used mode of operation when you are going for baud rate generation. Fine. Serial communication timing generate பண்றதுக்கு இந்த particular mode தான் நம்ம prefer பண்ணுவோம். Fine. Fine. Why we are preferring in this mode? Because on timer overflow, either in mode 0 or mode 1 or mode 3, we have to load the count value again into the timer register. Fine. But in the case of mode 2, no need to do that. It is auto reload. Whenever timer overflow occurs, again the count value, what you have put, again it will be reloaded. That's why it is termed as auto reload timer bar counter. Fine. In the case of mode 3, it is only applicable for timer bar counter 0. Fine. Timer bar counter 0 மட்டும் தான் எனக்கு என்ன ஆக போகுது mode 3 ல ஆபரேட் பண்ண முடியும். Fine. That means we call it as split timer mode. That means timer 0 ரெண்டா டிவைட் ஆக போகுது, TL0, TH0. TL0 it is going to work as a timer bar counter 0. Okay. Yes. Whereas TH0 என்னவா போக போகுது, it is going to be used only as timer. It cannot be used as counter. Fine. Split timer அப்படின்னு சொன்னோம்னா the entire 16-bit register of timer bar counter 0 is going to divide it into two sections. TL0 it is going to work as a 8-bit timer bar counter, and TH0 it is going to work as only 8-bit timer. It cannot be used as counter. Fine. Alla gavanikkanum, timer bar counter 0 is split into an 8-bit timer bar counter TL0, which uses timer 0 control bit, and an 8-bit timer alone TH0 uses timer 1 control bit. Fine. So idu nama innum sollala, the timer 1 timer 0 control bit அப்படினது நம்ம இன்னும் போடல. Okay, that portion Tcon la available in register Tcon, it is available. Fine. As of now, what we have to know, so we have to know about the word format of this register. Fine. If I am saying I want to enable a gate control, I have to put this bit as 1. If I want to configure it as timer, I have to put 0. Counter means 1. Based upon the mode of operation you are going to configure, these 2 bits should be returned. Fine. All the 8 bits, it must be decided by the software only. Fine. It cannot be set or reset by the hardware. We programmer have to decide what about the condition of this bits. So this entire word format 8-bit, I have to write it in the Tmod register to configure the timer bar counter. Fine. Kindly remember, it is not a bit addressable SFR. Tmod register is not a bit addressable SFR. That means always you have to write a 8-bit value in the Tmod register, and you have to use this word format. Fine. Okay. So for example, we will go with an example. Find the value to be loaded in Tmod register to configure the timer bar counter as follows. Fine. So timer bar counter 0 as timer in mode 2 without gate control, and timer bar counter 1 as counter in mode 1 with gate control. Can you people find the bits? Timer bar counter 0 bits sonna endha 4 bit use pannum? To configure the timer bar counter 0, which of the 4 bit I have to use? Lower 4 bit or upper 4 bit? Yes, bit number 3 to 0. Fine. Fine. We will go with the bit number 3. What I have told? Without gate control. So what you have to fill at Tmod point 3? What I have to fill at Tmod point 3? Third bit of Tmod register, which is gate control. Enable panma? No. Yes, very good. 0. What about the operation timer or counter? What I am going to configure? Whether I am going to configure as timer or counter? Timer. So what I have to fill at this particular question? 0 only. Fine. What about M1 and M0? I have to configure in mode 2. What about the value I have to fill at M1 and M0? Yes. Yes, very good, Sajis. Yes, very good. Fine, very good. 1 0. Very good, Anthony Surya. Fine. Can you people understand this thing? Yes. How I am filling this? Based upon the requirement, I am filling the bits. Fine. Similarly, tell the 4 bits, upper 4 bits. Kindly find out and tell. It need gate control. It should be configured as counter in mode 1. 3 things you have to note down. Yes, very good. Very good, Anthony Surya. What about others? Yes, very good, Danya. Very good. So 1101. How 1101? I need gate control. I'm going to configure it as counter. So C, here it must be 1. M1, M0, mode 1. That means 0, 1. Fine. What about the 8-bit data now? D2H. So this value must be loaded into your Tmod register. The value you load configuration of timer bar counter 0 and 1 can be done. That's all. Fine. Is it clear up to this? Have you people understand the meaning and the functionality of Tmod register? Yes. To configure the mode of operation, you are going to use Tmod register. Fine. Next, we will go with Tcon register. Fine. So Tcon name itself indicate timer bar counter control register. Timer control register. That's why it is termed as Tcon. Fine. So it is also going to have a word format. TF0, TR1, TF0, TR0. Fine. This 4 bits, upper 4 bits, it is used for timer control flag. Timer control or flag bit. I will say what is the meaning for this. Fine. The remaining 4 bits, it is used for configuring your interrupt type or flag. Fine. Don't get confused. The name of the register is Tcon, but it is used for 2 purposes. One is to control the timer bar counter operation. The another one is it can be also used to choose or program your interrupt. Fine. But the name is Tcon only. Fine. We are going to concentrate only the upper 4 bit because it is going to related with the timer operation, timer or counter operation. Yes, is it clear? In Tcon register, the MSB 4 bits, it is going to be used to control the operation of timer bar counter 0 and 1. Fine. Here we go. TF1 meaning enna timer 1 overflow interrupt. Fine. When this bit will get set, any guess? எப்ப இந்த bit set ஆகும் சொல்ல முடியுமா? Any guess? Timer overflow interrupt bit அப்படினா சொல்லிட்டேன். When this bit will get set? I have given the answer. Yes, very good. Whenever the timer overflows, that means maximum to minimum value change occurs. Okay, at that point of time, this is set by the hardware. We no need to set this. Okay, it is set by the hardware only. Is it clear? That's why it is termed as flag bit. Flag na meaning in the general status. Fine. This flag, it is going to indicate timer overflow flag bit. It is going to indicate whether overflow occurred or not. Fine. Okay. It is set by the hardware. Fine. That's fine. What about reset? Yes, it is also reset by the hardware. When it is going to reset? When an interrupt occurred, it has to be serviced, correct? When timer overflow occurred, that interrupt, it has to be enter into the service program. At that point of time, automatically this bit will get reset. So this bit must not be set or cleared by the programmer. It is set or cleared by the hardware only. Is it clear to everyone? Timer 1 epalla overflow agudho when the bit set ayid. Fine. When it is going to get reset? When the timer interrupt occurs, it has to be serviced. So ISR routine of timer overflow interrupt 1 ulla pona odane this bit automatically getting reset. Fine. Interrupt occur agarappa set agum. And the interrupt kundana service nadakra time la it is going to be reset. Fine. Then TR1 timer run control bit. Fine. Timer run control bit. Apna meaning enna? In software through program, if you want to enable the timer operation or disable the timer operation, you can use this bit. This is the TRX again. TRX means what? TR1, TR0. Fine. நீங்க gate control enable பண்ணா ரெண்டு விஷயத்தை டிபெண்ட் பண்ணி இருக்கும் உங்களோட டைமர் ஆபரேஷன். ஒன்னு external gate control, the another one is this TR1 and TR0 bit. Fine. That means this is set by the software. Programmer தான் set பண்ணணும். Whenever you want to run the timer, this bit must be set. Fine. To disable the timer bar counter operation or to stop the timer bar counter operation, we have to reset this. Fine. Is it clear? So, but TR1, TR0, these two are timer control bits. These two bits are flag bit. Fine. Whenever an overflow occurs, at that point of time, these two bits it is going to indicate. That's why we are saying it as timer overflow bit 1, timer overflow bit 0. These two bits are for timer 1 control and these two bits are for timer 0 control. Is it clear to everyone? Is it clear to everyone? Yes. So which register I want to configure? Which register I must use to configure the timer bar counter? Timer bar counter configure பண்றதுக்கு எந்த register use பண்ணனும்? Can you type it in the chat? Yes, very good. To control the operation, run பண்றது stop பண்றதுக்கு எந்த register use பண்ணனும்? Yes, in Tcon, which bits must be used to enable or disable the timer? Tcon la எந்த bit நம்ம யூஸ் பண்ணி timer நம்ம disable or enable பண்ண முடியும்? TR1 and TR0. Very good, very good. Fine. I hope everyone understand this concept. See, this தெரிஞ்சா timer easy program பண்ணிடலாம். Fine. See, we have written delay programs, correct? நம்ம லேப்ல delay programலாம் எழுதுறதுக்கு காமிச்சு எப்படி எழுதுறதுன்னு சொல்லி கொடுத்தோம், correct? That delay program is approximate only. It is not a exact delay time. Fine. When for generating an accurate time delay, you have to use the hardware timer. Fine. Fine. So for LED blinking program ku na timer programming nalla kathukta enna pannalam? Time generation ku enna pannalam? I can program the timer bar counter. Fine. Yes, is it clear? Fine. The remaining 4 bits, it is for interrupt. Okay, adu enna na solliren. This part of thing don't worry, later interrupt படிக்கிறப்ப இத நம்ம ரீகலெக்ட் பண்ணிக்கலாம். Fine. So இப்போதைக்கு நமக்கு தெரிய வேண்டியது என்ன அப்படினு பாத்தீங்கன்னா we are having 2 interrupts, external interrupts, correct? What are the 2 external interrupts? Can you people type it in the chat? 2 interrupts, external interrupts we are having. Totally we are having 5 interrupts. Adha 3 வந்து internally generated, 2 வந்து externally generated னு சொல்லிருப்போம். Fine. What about the 2 externally generated interrupts? INT 0 bar and INT 1 bar. Yes, correct? Yes or no? Yes, fine. So IE1 and IT1, these 2 bits for external interrupt 1, and these 2 bits IE0 and IT0 is for external interrupt 0. Fine. So on the interrupt நம்ம என்ன பண்ணலாம்? Program பண்றதுக்கு இந்த particular 4 bits use பண்ணிக்கலாம். But name of the register is going to be Tcon only. Fine. Okay, என்னென்ன purpose னு பார்க்கலாம். External interrupt 1 flag bit. That means whenever external interrupt occurred, இந்த flag எனக்கு என்ன இருக்கும்? Set ஆயிருக்கும். Similarly, அந்த interrupt ஓட service routine போனா இந்த flag reset ஆயிடும் automatically, like your timer overflow flag, correct? So external interrupt 1 flag bit. Fine. Is it clear? External interrupt 1 எனக்கு வந்து occur ஆயிருந்துச்சுன்னா இந்த bit set ஆகும் hardwareல. Once service routine போனுச்சு அப்படின்னா it will get automatically reset. Fine. The next one we have to understand this interrupt type select bit for external interrupt. Fine. When I say an interrupt, it can be of 2 types, level triggered or edge triggered, correct? எனக்கு பின் வந்து லெவல் மெயின்டைன் ஆனா இன்டரப்ட் நடக்கணுமா இல்ல எட்ஜ் சென்ஸ் ஆனா இன்டரப்ட் நடக்கணுமா? That has to be decided by an interrupt, correct? In the case of 80-85 interrupts, that things are fixed. Trap பொறுத்த வரைக்கும் என்ன படிச்சோம்? Both edge and level sensitive. Fine. RSC 7.5 edge sensitive. Fine. RST 5.5, 6.5, and INTR level sensitive. Fine. There we know we cannot able to program the sensing of the interrupt, but here we can program. The interrupt in a low level maintain aguma. Correct? Or see in the bit nana set panna poren. In the bit na set panna meaning enna when interrupt will get sensed during falling edge. Whenever falling edge happen at the interrupt pin, it is going to sense. Fine. Then I reset panni vechina meaning enna when low level is maintained at the time it is considered as an interrupt. Fine. Is it clear to everyone? Edge trigger level trigger அதை நம்ம program பண்ணிக்கலாம். Edge trigger அப்படினா falling edge ல தான் interrupt sense ஆகும். Level trigger சொன்னா low level maintain ஆனா மட்டும் தான் sense ஆகும். That's why we are saying INT 0 bar, INT 1 bar. These 2 bits for interrupt 1, external interrupt 1. The next 2 bits it is for external interrupt 0. That's all. Is it clear up to this? Tmod, Tcon. Fine. Okay. Regarding Tcon register, it is bit addressable. Bit addressable. Say for example, if I want to run the timer 1, if I want to enable the timer 1, which instruction I have to use? Timer 1 na run பண்ணனும்னா இந்த பிட் நான் என்ன பண்ணனும்? TR1 செட் பண்ணனும். கரெக்ட்டா? அதுக்கு என்ன இன்ஸ்ட்ரக்ஷன் யூஸ் பண்ணுவீங்க? Yes, can you people type? To set the bit TR1, what you have to use? What about the instruction? Timer 1 na run பண்ணனும் அப்படினா இந்த பிட்டை செட் பண்ணனும் TR1. Yes, very good. Set B TR1 அப்படினு யூஸ் பண்ணலாம். or set B Tcon.6. both are going to be same only. But நம்ம assembler எப்படி எடுத்துக்கொண்டத பொறுத்து it will vary. Fine. Generally you can use the name of the bit. TR1 அப்படினு யூஸ் பண்ணலாம் instead of Tcon.6. Fine. Yes. Okay. If I want to stop the timer 0, what I have to use? Timer 0 stop பண்ணனும், disable பண்ணனும். So what I have to use? I am speaking about timer 0. Timer 0, I have to stop. What must be the instruction we can use? Yes, very good. CLR TR0. Fine. Based upon the need, using bit instruction, you can control it. Fine. Now you people realize what is the importance of bit operation. Fine. Without affecting the other bits in the Tcon, you can able to set or clear individual bit. Fine. So here bit operation is very, very important. It's going to play a important role. Fine. Okay. Now we will get into the registers. Already I have told you TH1, it is an 8-bit SFR used to hold the higher byte of count value of timer bar counter 1. Similarly, it is going to use for lower byte of the count value. Fine. TH0, higher byte of timer bar counter 0 value. TL0, lower byte of timer bar counter 0 value. That's all. Fine. So all the 6 SFRs. Adulude purpose ennu purinjudha ellarkume? Is it clear now? Is it clear now up to this? Yes, fine. Konja faster polam because we have to complete the syllabus also. Fine. So this diagram, carefully note down. Fine. Here we have one switch. So it is going to be a mux. In the mux select பண்ற அந்த control input வந்து C/T bar ல இருந்து வருது. Okay. Where it is present? Present in the Tmod register. Fine. If this bit is 1, it is connected to the counter input. Fine. TX அப்படினா meaning என்ன? இங்க x ன்னு போட்ட meaning என்னப்பா? X equal to 0 na timer 0. Fine. Yes. Yes, very good. You can place either 0 or 1 because we are having 2 timer bar counter. Both are having similar hardware only. Fine. Fine. Both are having similar hardware only. Fine. Nalla gavaninga. If in this particular diagram, if C/T bar equal to 0, what it means? It is connected to this portion. What about this portion? FOSC divided by 12. That means it is going to function as a timer now. Correct? Is it correct or not? The diagram paathe neenga purinjikkum. Fine. If C/T bar equal to 0, counter input depend பண்ணி இருக்காது. எதை depend பண்ணி இருக்கு? Internally generated pulse depend பண்ணி இருக்கு. That's why it is functioning as timer now. Fine. Then you have a switch here. இந்த switch க்ளோஸ் ஆனாதான் எனக்கு டைமர் ஆபரேஷன் நடக்கும். தட் மீன்ஸ் இங்க வர்ற பல்ஸ் இங்க உள்ள போகும். இந்த switch ஓபன் ஆயிடுச்சு அப்படின்னா you won't be getting the clock pulse. T clock அப்படின்னு போட்டுருக்குது டைமர் மாடியூலுக்கு போற கிளாக்கிங். ஃபைன். இந்த switch நமக்கு எப்ப க்ளோஸ் ஆகும்னு சொல்ல முடியுமா? When the AND gate output is 1, the switch will get closed. Otherwise, it is going to be open. Fine. In the AND gate, kandipa எனக்கு 1 இருக்குன்னா, what is the need now? In the AND gate, kandipa எனக்கு output 1 வரணும்னா, what are the things you have to take care? On seeing this portion, you can tell. On seeing this portion, you can tell. See, in the diagram of path, பயந்துக்க வேணாம். It's very, very simple only. Fine. Yes. TRX kandipa 1 இருக்கணும். What is TRX? TR1, TR0. டைமர் பார் கவுண்டர் எனக்கு ரன் பண்ணணும் அப்படின்னா இந்த பிட்டை நம்ம கண்டிப்பா என்ன பண்ணணும்னு சொன்னோம், செட் பண்ணணும்னு சொன்னோம். கரெக்ட்? ஃபைன். இது மட்டும் பண்ணா போதுமா? இது மட்டும் பண்ணா போதுமா? வாட் அபவுட் த அதர் இன்புட் டு த AND கேட்? இது கண்டிப்பா என்ன வரணும்? எஸ், த அவுட்புட் ஆஃப் ஆர் கேட் ஆல்சோ மஸ்ட் பி 1. ஃபைன். ஃபார் திஸ் வாட் அபவுட் த கண்டிஷன் நவ்? இந்த ஆர் கேட்டோட அவுட்புட் எப்போ 1 வரணும்? If any one of the input is 1, that's enough. Fine. நல்லா கவனிங்க. If I say gate control 0 அப்படின்னா மீனிங் என்ன? Tmod ரெஜிஸ்டர்ல உள்ள கேட் கண்ட்ரோல் நான் 0 ன்னு ஃபில் பண்ணிட்டா ஆட்டோமேட்டிக்கா நாட் கேட்டோட அவுட்புட் என்ன? 1. So இங்க நமக்கு 1 வந்துருது. That means the timer operation it is going to depend only on the software bit. TR1, TR0 மட்டும் தான் டிபெண்ட் பண்ணிருக்கு. Yes or no? Yes or no? If I say gate control is 0, fine, then the timer operation merely depends on TR1 and TR0, correct? Yes or no? Fine. If I say gate control equal to 1, what about the input to one of the OR gate? The OR gate for one input enna aayidudhu? Kandipa 0 aayidudhu. So the other input must be 1. That means when you say gate control neenga use panna poringa appadina you cannot able to have external interrupt 0 or 1. நீங்க கேட் கண்ட்ரோல் வேணும்னு சொன்னா அதுக்கு ஒரு பின் கொடுத்தாகும். கரெக்டா? Yes or no? If I need gate control, I have to provide one more hardware pin. ஏற்கனவே எல்லா பின்னும் நம்ம ஃபங்க்ஷனாலிட்டி அசைன் பண்ணியாச்சு. ஸோ இப்போ என்ன பண்ணிக்கணும்? Instead of interrupt, find that pin, it can be used as a gate control pin. What it means? Now your timer operation depends on TR1 and TR0 as well as INT0 bar and INT1 bar. Is it clear to everyone? Gate control வேணான்னு சொல்லிட்டோம்னா சாஃப்ட்வேர் மூலமாவே நான் டைமரை ரன் பண்ணிக்கலாம், ஸ்டாப் பண்ணிக்கலாம். Fine. If I told gate control is needed in my application at that point of time, which is going to be used as a gate control? Which pin is going to be used as a gate control? Which pin is going to act as a gate control? Diagram பார்த்து கிளியரா சொல்லலாம். கேட் பிட். இதுல எதெல்லாம் பிட்னு புரிஞ்சுக்கோங்க. C/T bar இது Tmod ரெஜிஸ்டர் பிட். கேட் கண்ட்ரோல் இது பிட். ஃபைன். TRX இது பிட். Tcon ரெஜிஸ்டர்ல உள்ள பிட். ஃபைன். Now my question is gate control 0 போட்டா பிரச்சனையே கிடையாது. It only depends on TRX. That means TR1 or TR0 of Tcon register. Fine. If I put gate control equal to 1, it depends on two factors. One is TR1 and TR0 bit. The other one is it is going to depend on the status of or the logic of interrupt pin. So at that point of time, you have to sacrifice the external input. Fine. INTX pin. Okay. INTX, that means INT0 or INT1 bar. It must be used as a gate control. Fine. Okay. This timer operation sonna nam enna pannom? C/T bar 1 போட்டோம். Correct? If I say it is counter operation, if I say it is going to be a counter operation, at that point of time, where it is connecting? It is connecting to the counter input. The ரெண்டு diagram க்கு difference பாருங்க. Timer அப்படினா எதை டிபெண்ட் பண்ணி இருக்கு? Internally generated clock pulse. Counter அப்படினா எதை டிபெண்ட் பண்ணி இருக்கு? External counter input. Is it clear to everyone? Is it clear to everyone? இந்த டைமரை நீங்க எனேபிள் பண்றதும் ஸ்டாப் பண்றதும் இந்த போர்ஷனை டிபெண்ட் பண்ணி இருக்கும். ஃபைன். டைமரா கவுண்டரான்றது இந்த மக்ஸோட பொசிஷனை பொறுத்து இருக்கும். which input it is going to be given for your timer bar counter register. Fine. I hope up to this clear to everyone. If you people have any doubt, you can ask. So Tmod, Tcon, using this two register only, we can able to choose the mode of operation and to enable or disable the operation of timer bar. Yes, is it clear now? Yes. Shall I proceed? Shall I proceed? Yes. Okay, fine. First, we will go with the mode 0 operation. Fine. This is நம்ம பார்த்ததெல்லாம் என்னது என்னென்ன ரெஜிஸ்டர் இருக்கு அதனுடைய ஃபங்க்ஷனாலிட்டி என்ன எப்படி அதை ப்ரோக்ராம் பண்றதெல்லாம் பார்த்தோம். Fine. Now we are going to discuss about the mode of operation. Fine. So this is the rare mode of operation used. Fine. See why this mode of operation அப்படின்னு பார்த்தோம்னா the older peripherals, okay, which are interfaced with 8051 microcontroller, which need this particular timer. Fine. என்ன அப்படின்னு பாத்தீங்கன்னா உங்களுடைய மிஷின் சைக்கிளை divided by 32 பண்றதுக்கு தான் மெயினா இந்த பர்టిక్యులர் மோட் ஆஃப் ஆபரேஷன். ஃபைன். இதனோட ரோல் என்னன்னு பார்க்கலாம். ஃபைன். Here you can see TH1 it is going to be a 8-bit register as it is use ஆகுது. Then lower 5 bit of TLX. அப்படின்னா டோட்டலா எத்தனை பிட் ஆயிடுச்சு? Totally how many bits? From TLX we are taking only 5 bit. From THX we are taking 8 bit. So totally it become how many bits? Kindly type it in the chat. Yes, very good. 13. Fine. Here what I am coming to say is this particular 5 bit. What about the minimum and the maximum value we can have? The 5 bits minimum value enna irukkalam? 0 0 0 0 0. Correct? Binary. Fine. What about the maximum value you can have? 1 1 1 1 1 in binary. Can you people convert it into decimal number and say what about the minimum and the maximum value you can have in the register? Can you type it in the chat? நான் போட்டுக்கிறது பைனரியில போட்டுருக்கேன். இது எனக்கு டெசிமல்ல கேட்டிருக்கேன். மினிமம் வேல்யூ 0, டெசிமல்ல மாத்தினால 0 தான் வரப்போகுது. What about 5 ones? இந்த டெசிமல்ல மாத்தினா என்ன வேல்யூ கிடைக்கும்? Can you type it in the chat? Binary to decimal conversion நமக்கு ஞாபகம் இருக்கும்னு நினைக்கிறேன். Yes, very good Karthikeyan. Classroom 2ல Karthikeyan type பண்ணிருக்காரு. Sajesh, very good. Shivakumar, very good. Fine, 31. Fine. அப்படின்னா மீனிங் என்ன? Minimum count value is 0, maximum count value is 31. Okay. Can you people say if I put 0 here in the lower 5 bit, how many count it can go for overflow? And you people type it in the chat. நான் வேல்யூ வந்து இப்போ 0000 போட்டிருக்கேன். ஃபைன். இனிஷியலா 0000 பைனரியில நான் போட்டிருக்கேன். ஃபைன். இனிஷியல் வேல்யூ. How many pulses it need so that TL0 will get overflow? Can you type it in the chat? No Shivakumar, it's not 33. 0 ல இருந்து 31 வரைக்கும் கரெக்டா? No Anthony Surya, it is not 6. Initial count value 0000 இருக்கு. Yes, very good Loga Sneka, very good. I am expecting this answer only. Fine. When overflow occur? From 0 to 31. 31 count ஆயிடுது கரெக்டா? Overflow ஆனா இன்னொரு count ஆகும். Then only it become again 0. Correct? So how many count it need to get overflow? 32 counts. That means for every 32 pulse input, this is going to overflow. When this get overflow, it is going to provide a single clock pulse to THX. What it mean? What it mean? Already the input frequency is divided by 12. Again to divide it by 32, we are going for this particular method. I hope everyone understands this. Correct? So THX is an 8-bit timer bar counter register, and TLX it is a 5-bit prescaler. So the pulse input will be divided by 32. For every 32 T clock pulse input, TLX will generate a clock pulse to THX. Apna meaning enna? In the 5 bits வந்து 32 bit. I mean again this frequency is going to be divided by 32, not 32 bit. Again the pulse input is going to be divided by 32. That means what? FOC divided by 12 divided by 32. Fine. What about the frequency we are getting into THX now? Frequency getting to THX is FOSC divided by 12. That is again divided by 24. Sorry, 32. Or simple words, we can say 12 into 32. Like this also I can write. Wait a minute. I am typing in the chat. Okay, 12 into 32. This is going to be FOSC divided by 384 in decimal. Refer the chat. I am typing in the chat. Okay, what about the frequency getting into THX now? FOSC divided by 384. This particular thing is required in some application. Okay, that is in older system. Fine. அதுக்கு தேவையான clock generate பண்றதுக்கு தான் இந்த particular mechanism போடும். Fine. Whatever the operating frequency of the crystal, it is first getting divided by 12. Fine. So already நம்ம என்ன பார்த்திருக்கோம், one machine cycle க்கு ஒரு pulse இங்க வரும். Again it is further divided by 32. Fine. That means divided by 384. So what about the crystal value you are using? That frequency is divided by 384. That is the operating frequency of THX now. So it is a 8-bit register. So for every one pulse getting into THX, it is getting increment by 1. Fine. When this will get overflow, TF flag will get set. நல்லா கவனிச்சுங்க தெரியும். இந்த TFX அப்படிங்கிறது எந்த bit? எந்த registerல உள்ள bit? TF1, TF0. Which is available in which register? Timer overflow flag bit. Yes, very good. Tcon register la உள்ளது. Fine. So the set ஆனச்சுனா meaning என்ன? Interrupt will be generated. That's all. So that about the operation of this mode 0. The frequency of pulse input to THX is T clock divided by 32, because for every 32 count, this it is going to generate one pulse. So FOSC divided by 12, again it is divided by 32, which is equal to FOC by 384. As the count rolls over from all ones to all 0, timer overflow occurs. So which is going to generate the interrupt. Fine. Also the timer interrupt flag gets set. Interrupt generate ஆகிற அதே டைம்ல இந்த flag automatically set ஆயிடும். Fine. That's all. Now the condition for timer overflow in mode 0. நல்லா கவனிங்க. நான் ஆல்ரெடி சொன்னேன். என்ன சொன்னேன்? THX, it is a 8-bit register. இதுல எல்லா வேல்யூஸும் 111 இருக்கணும். TLX ல the upper 3 bits are don't care. Lower 5 bits are used for prescaling. Fine. So 1F, it is going to be 31 in decimal. Fine. Is it clear now? When clock comes at this point of time, overflow occurred in this mode. That's all. So this is the condition for overflow in mode 0. இந்த condition எப்ப நடக்குதோ அப்ப overflow நடந்துடும். Fine. All 13 bits, if it is entirely 1111, it is changing from 00 from 111 to 0000, overflow occurs. Fine. Don't forget, even though I am saying 13-bit timer bar counter can also be termed as 8-bit timer bar counter with 5-bit prescaler. Fine. Is it clear now? Is it clear now? Yes. Yes. Okay. Mode 1, it's very simple. TLX, THX. Rendu combined ஆகி பாத்தீங்கன்னா it is going to function as a 16-bit register. நல்லா கவனிக்கணும். When this value changes from FF to 00, ஒரு pulse இங்க போகும். So THX bit increment ஆயிட்டே வரும். Fine. For every one pulse, here THX and TLX are cascaded and work as a 16-bit register. Fine. If the count rolls over from FFH to 0000H, here overflow occurs. That's all. So இங்க நமக்கு prescaling la கிடையாது. Fine. This is going to happen. So the higher byte is lower byte. Fine. So எப்ப எனக்கு FF ல இருந்து இந்த value 0000 change ஆகுதோ, at this point of time, mode 1 la timer flow occur. That's it. Is it clear now? And the 13-bit இங்க 16-bit. That's why it is termed as 16-bit. இங்கேயும் count overflow ஆனா கண்டிப்பா என்ன ஆகும்? 0 தான் fill ஆகும். Fine. In mode 0 and mode 1, so far overflow occurana ennagu count value becomes 0. It changes from all 1s to all 0. Fine. Then coming to mode 2. Mode 2 பொறுத்த வரைக்கும் நல்லா கவனிங்க. Pulse input எதுக்கு போகுது? TLX க்கு போகுது. கரெக்ட்டா? Fine. So what about the maximum count value we can have here? Can you people type it in the chat? Idhila maximum count value f of h சொன்னோம். கரெக்ட்டா? Here it is 8-bit timer bar counter. What about the maximum value we can put in TLX? FF only. Fine. நல்லா கவனிக்கணும். இனிஷியலா எனக்கு ஏதோ ஒரு வேல்யூ இருக்குன்னு வச்சுக்கலாம். Fine. TLXல THXல நான் டைமரை ரன் பண்ண எனேபிள் பண்ண உடனே this count value get loaded into TLX. Fine. Lower byte la load ஆயிடும். Fine. Now it is going to work as a timer bar counter register. Increment ஆயிட்டே இருக்கு. Fine. நல்லா கவனிங்க. On overflow TFX set ஆகும். At the same time this buffer will get enabled. இந்த buffer enable ஆனா என்ன ஆகும்? THX ல உள்ள count value again loaded into TLX. Is it clear now? TLX works as a 8-bit timer bar counter and THX holds the 8-bit count value which is going to be reloaded into TLX every time during overflow. Fine. If count rolls over from f of h to 00 in TLX, timer overflow occur agum. At the meanwhile, this buffer is going to enable whatever the value I have loaded in THX is getting reloaded into TLX also. Fine. So on the condition mode 0, mode 1 la, on overflow the count value become again 0000 only. Fine. In the case of auto reload mode, the value is getting reloaded again and again in TLX register. Is it clear to everyone? THX la ulla value change agadu until I reprogram it. That's why it is termed as auto reload mode. Fine. On every 1 clock pulse, TLX is going to increment. When TLX get overflow, the count value what I have initially loaded in THX will get auto reload into TLX. Whenever I say X, it means either 0 or 1. Fine. Is it clear? Is it clear now? What is the difference between other mode and mode 2? In other modes, the count value will not get reloaded again. Whereas in the case of mode 2, it will get reloaded. When the reloading happens, when the count value gets reloaded in mode 2, can you type it in the chat? The count value again and again load out. Yes, during overflow, very good. Whenever the timer get overflow, at that time the reloading happen automatically. That's it. See, this particular mode, it is used for generating the serial communication baud rate. Fine. Later point of time, we will discuss about it. Fine. That's all about mode 2. So, inge namakku overflow condition எப்படி இருக்குன்னு பார்த்தோம்னா, if count to be loaded is 37 value இருக்குன்னா maximum value reach ஆகுனா எனக்கு என்ன வரும்? FR. So இதுக்கப்புறம் ஒரு clock pulse வந்துச்சுன்னா எனக்கு என்ன ஆகும்? It becomes 00. Immediately on reload, again 37 will be loaded. So அதனால தான் இப்படி போட்டுருக்கோம். So again இந்த value இப்படி change ஆயிடும். So this is going to be happen in a loop. Fine. Again and again on timer interrupt, this value 37 will get loaded again. That's it. Okay, that's all about the mode 2 operation. Fine. Coming to mode 3. Already I have told you mode 3 it is applicable only for timer 0. Mode 1 நீங்க அத mode 3 ல configure பண்ணீங்கன்னா automatically அந்த timer bar counter operation stop ஆயிடும். Please understand one thing, whatever the value you are loading in Tmod register, it is going to determine the mode of operation. Timer 0 mode 3 la operate ஆகும். Whereas timer 1 the operation of the timer bar counter will get freezed. Fine. Mode 3 la configure பண்ணீங்க timer 1 அப்படினா automatically என்ன ஆயிடும் அதோட operation stop ஆயிடும். Fine. Okay. So if timer 1 is configured in mode 3, fine. When we can go for mode 3 அப்படினு பார்த்தோம்னா actually we are having only 2 timer bar counter. If I need one more timer, I can use this particular mode so that the timer bar counter 0 is going to be divided into 2 timers. Okay, fine. If timer 1 is configured in mode 3, it gets stopped and it simply hold the count. That's all. Timer 0 register TL0 and TH0. Now it is going to split into 2 register. Fine. Adla TL0, it is going to work as a timer bar counter with TR0 and TF0 control. Fine. Timer 0 oda control bit TL0 ku use agapod. If I want to stop TL0 now, you have to clear TR0. Yes, is it clear? Timer 0 ரெண்டா உடைஞ்சிருச்சுப்பா. அதுல ஒரு பாதி TL0 இன்னொரு பாதி TH0. கரெக்ட்? இதுல TL0 என்னவா வர்க் ஆகும்? டைமர் பார் கவுண்டர். அதோட கண்ட்ரோல் பிட்ஸ் என்ன? TR0 and TF0, which is nothing but the same thing. Fine. Coming to TH0, it only works as timer only. Fine. It cannot be configured as counter. Fine. With control bits from timer 1. நல்லா கவனிச்சீங்கன்னா தெரியும். டைமர் 1 ஓட கண்ட்ரோல் பிட் தான் TH0 கண்ட்ரோல் பண்றதுக்கு யூஸ் ஆகும். Yes or no? Yes or no? Is it clear? If I configure, see, till now I have told you independent அப்படின்னு சொன்னோம். Independent timer bar counter சொன்னோம். அது கரெக்ட் தான். Fine. Till now, fine. Whenever I configure timer 0 in mode 3, at that point of time, the control bits from timer 1 is transferred to control the TH0 timer register. Fine. Is it clear? Timer 1 oda control bit இது என்ன ஆகுது? கடன் வாங்கி. Fine. Timer 0 control பண்றதுக்கு தான் TR0 and TF0. Correct? So அது TL0 க்கு யூஸ் ஆயிடுது. For controlling TH0 timer operation, TR1 and TF0 are borrowed. That means what? When you configure timer 0 in mode 3, timer 1 oda control bit sacrifice ஆயிடும். So இப்ப timer 1 ஸ்டாப் பண்ணனும்னா என்ன பண்ணனும்? mode 3 ல போடணும். கரெக்ட்டா? ஃபைன். அத ரன் பண்ணனும்னா எந்த மோட்ல ரன் பண்ணுமோ அந்த மோட கான்ஃபிகர் பண்ணா போதும். ஃபைன். The mode of operation can be changed. The start and stop operation cannot be done with TR1 and TF1 if timer 0 is configured in mode 3. எல்லாம் கவனிங்க. timer 0 mode 3 ல கான்ஃபிகர் பண்ணிட்டா the control bit of timer 1 is sacrificed. So to stop or start the timer, you have to use this particular concept. Timer 1 stop பண்ணனும்னா mode 3 ல போணும். ரன் பண்ணனும்னா எந்த மோட்ல ரன் பண்ண போறீங்களோ அந்த மோட கான்ஃபிகர் பண்ணா போதும். Simply by mode configuration, you can enable or disable the timer operation, timer 1 operation. Fine. When timer 0 is configured in mode 3, timer 1 can be used in mode 0 or mode 1 or in mode 2. But in this case, no interrupt will be generated as timer 0, TH0 taken over TF1 flag and TR1 flag. So, ரெண்டுத்தையும் எடுத்துக்கிட்டதுனால இங்க இன்டரப்டும் ஜெனரேட் ஆகாது, கண்ட்ரோலும் பண்ண முடியும். Is it clear now? இந்த டயகிராம் பார்த்தா புரியும். Fine. So timer 1 அப்ப எதுக்காக மட்டும் யூஸ் பண்ணிக்கலாம்? baud rate generator யூஸ் பண்ணிக்கலாம் in mode 3. Fine. Timer 1 can be used as baud rate generator when timer 0 is in mode 3. That's all. So அதுக்காக மட்டும் தான் யூஸ் பண்ணணும். Fine. Here you can see FOC divided by 12, C/T bar 0, everything okay. Fine. So நீங்க கவனிச்சீங்கன்னா தெரியும். இங்க counter input T0 டைரக்டா இங்க போயிடுது. Fine. Here you can see TR0, INT0 bar, then gate control. So this is as usual. Okay. இங்க TL0 தான் என்ன ஆகுது? 8-bit timer bar counter function ஆக போகுது. Control bits are from TR0 and TF0. Fine. Now coming to this, in the particular இது பாருங்க, TH0 can be only used as timer. Fine. இங்க count input நமக்கு கிடையாது. அதனால ஏன் கிடையாது? mode configuration la கிடையாது. See, timer 0 ரெண்டா split ஆயிடுச்சுன்னா TL0 ஒரு timer bar counter, TH0 can be only timer அப்படின்னு படிச்சோம். Fine. That means what? The control bits are used from the timer 1. So TR1 use பண்ணி தான் இதை control பண்ண போறோம். TF1 it is from the timer 1. Fine. So timer 1 overflow interrupt தான் நம்ம யூஸ் பண்ணிக்க போறோம். When I say TH0, timer bar counter 0 can be divided into two things. One is timer bar counter, okay, that is from TL0. The another is from TH0. It can be only used as timer. So அதனால டைரக்டா இங்க மக்ஸ் எல்லாம் கிடையாது, நமக்கு டைரக்டா இந்த ஸ்விட்ச் இன்புட்டை மட்டும் தான் கண்ட்ரோல் பண்ண முடியும். Fine. The frequency input is from the internally generated thing only. Fine. So that's all about the mode 3 operation. Fine. Mode 3 புரிஞ்சிக்கிறதுக்கு கொஞ்சம் கஷ்டமா இருக்கலாம், but it's very simple only. Fine. ஒரே ஒரு விஷயம் ஞாபகம் வச்சுக்கணும், டைமர் 0 ரெண்டா டிவைட் ஆகுது. Fine. டைமர் 0 ஓட கண்ட்ரோல் பிட் TR0 TF0 ஆல்ரெடி உள்ளதுதான். But for TH0, for control input, TR1 and TF1 are used. Fine. That means timer 0 நீங்க mode 3 ல கான்ஃபிகர் பண்ணிட்டாலே timer 1 ஓட கண்ட்ரோல் பிட் இந்த பர்టిక్యులர் TH0 காக sacrifice ஆயிடும். That's all. Okay, so that's all. So here you can have overflow interrupt for TL0 and TH0. So இது ரெண்டுத்துக்கும் overflow control கொடுத்துருச்சுன்னா timer 1 ஆப்வியஸா என்ன கிடையாது, கண்ட்ரோலும் பண்ண முடியாது, overflow interruptum generate ஆகாது. That's the meaning for split timer. Fine. So that's all about the 4 modes of operation of timer counter of Intel 8051. Fine. Fine. இப்போ இது வரைக்கும் நம்ம பார்த்தது என்ன, எப்படி மோட் கான்ஃபிகர் பண்றது, எப்படி கண்ட்ரோல் பண்றது, modes of operation எப்படி இருக்கும்ன்றத பார்த்தோம். Fine. Now the very important thing we are going to discuss, how to load the count value. Fine. That's very very important. We will go with 2 examples. Okay. So இதுல overflow condition அப்படின்னா TL0 or TH0. எப்ப எனக்கு FF ல இருந்து 00 போதும், that point of time we will get overflow. Fine. Okay. Now it's a question, how to load the count value. Say for example, எனக்கு 5 count பண்ணனும் அப்படினா 5 count அப்படியே load பண்ணலாமா? That's the question now. Fine. Fine. Okay. Now we will get into, as timer bar counter of 8051 is an up counter, the desired count value should not be loaded directly. இதுதான் லாஸ்ட் கிளாஸோட எண்ட்ல பேசிட்டு இருந்தேன். எனக்கு 5 கவுண்ட் போடணும் அப்படின்னா நான் 5 போட்டா என்ன ஆகும், ஃபர்ஸ்ட் கவுண்ட் ஃபர்ஸ்ட் பல்ஸ் வர்றப்ப 6, அடுத்து 7, அடுத்து 8, அடுத்து 9, அடுத்து 10, ஓவர்ஃப்ளோ அக்கர் ஆகுமா? டெஃபினட்டா அக்கர் ஆகாது. That means whenever I'm asking to count the timer bar counter, fine, after the count gets over, it should interrupt the microcontroller. So அதனால கவுண்ட் நம்ம என்ன பண்ண முடியாது, அப்படியே லோட் பண்ண முடியாது. As it is a up counter, count value டைரக்டா லோட் பண்ண கூடாது. Fine. எப்படி லோட் பண்ணோம் அப்படின்னு பாத்தீங்கன்னா, the count value to be loaded, we have to calculate using this concept, maximum count value minus desired count value plus 1. Can you people say a count? Can you people say a count value? Can you people say a desired count value? ஒரு ஸ்மால் நம்பர் ஏதாவது ஒன்று சொல்லலாமே, single digit number. Yes, 8. Fine. நல்லா கவனிங்க. Anthony Surya told the count value as 08H. Correct? Now the count value, desired count value is 08H. Fine. So அதுக்கு நான் லோட் பண்ணக்கூடிய கவுண்ட் என்னவா இருக்கணும், maximum count value minus desired count value plus 1. Now we will consider mode 2 operation. Mode 2 அப்படின்னு சொன்னோம்னா maximum count value என்ன? What about mode 2? 8-bit timer bar counter with auto reload. So what about the maximum count value? What about the maximum count value? Mode 2 ன்னு சொன்னோம்னா FF. Very good. Fine. So இப்போ நான் என்ன பண்ணணும், FFH minus 08H plus 1. So this is the desired count. Sorry, this is the count value to be loaded. நான் 8 count value desired count நான் choose பண்ணனா, count என்ன load பண்ணனும் அப்படினு பாத்தீங்கன்னா FF minus 8 plus 1. So what about the value you will be getting? F8H. என்ன value கிடைக்கும்? F8H. Is it correct or not? Is it going to be correct or not? FF minus 08. Yes. So the calculator la போட்டு பாருங்க. Hexadecimal number FF minus 8 plus 1 பண்ணீங்கன்னா will be having F8. Fine. Now you are going to count. For first count, what about the count value? F9. Second count, FA. அடுத்து FB, FC, FD, FE, FF. 7 counts பண்ணியாச்சு. 7 countsல என்ன வேல்யூ கிடைச்சிருக்கு? FF. 8 count பண்றப்ப என்ன ஆகும்? Can you imagine? When I am doing the 8th count, what is going to happen? See, F8 ல இருந்து 7 count பண்ணா FF. 8 count பண்ணா என்ன ஆகும்? Yes, very good Sajesh. Very good Danya. Very good. Count becomes 0 0. FF ல இருந்து 0 0 போனா என்ன ஆகும் ஆட்டோமேட்டிக்கா? When the count changes from FF, maximum value to minimum value, what we call it as? Timer maximum value ல இருந்து minimum value போனா அந்த phenomena பேர் என்ன சொன்னோம்? Overflow. Very good. Timer overflow ஆச்சுன்னா என்ன ஆகும் ஆட்டோமேட்டிக்கா? Timer overflow interrupt happen. அப்ப 8 கவுண்ட்க்கு கரெக்ட்டா எனக்கு என்ன ஆயிடும்? Interrupt generate ஆயிடும். So that CPU can run. Fine. நல்லா ஞாபகம் வச்சுக்கணும். ஹார்ட்வேர் டைமர் போயிட்டா கவுண்ட் வேல்யூ கொடுத்துட்டு CPU it is going to do its regular routine. Fine. Timer எப்ப interrupt பண்ணுதோ அப்ப மீனிங் என்ன? The generated time is the desired time is generated. That is the meaning for that interrupt. So அப்ப நீங்க என்ன பண்ணலாம்? LED ஆன் பண்ணிக்கலாம். ஆன் பண்ணிட்டு you can do some other work. Fine. After the time is getting over, again interrupt வரும். LED ஆஃப் பண்ணிக்கலாம். So you can have a blinking of LED at regular interval. At the same time, you can do some other operation also. இப்போ உங்க processor time delay generate பண்றதுல engage ஆயிருக்கா? Or it is relieved to do some other work? I think somebody unmuted and trying to speak. I don't know who. Yes. Okay.
Yes, muted.
Fine.
Sir.
Okay. Fine. Okay. Can you people say whether the CPU is relieved when you are going for hardware timer? See, now CPU nu vechikalam. Fine. I will consider some of you as a timer bar counter. What I am going to tell, எனக்கு 5 minutes கழிச்சு நான் இதோட டாபிக் ஸ்டாப் பண்ணணும், செஷன் ஸ்டாப் பண்ணணும் என்கிட்ட சொல்லிடுங்க அப்படின்னு இன்ஃபார்ம் பண்ணிடுவேன். Fine. Now what I am going to do, I am going to continue the theory session. Fine. 5 minutes கழிச்சு ஆட்டோமேட்டிக்கா என்ன பண்ண போறாங்க? To whom I assign the role. 5 minutes கழிச்சு எனக்கு இன்ஃபார்ம் பண்ணுங்கன்னு சொல்றோமோ ஆட்டோமேட்டிக்கா அவங்க எனக்கு இன்ஃபார்ம் பண்ணுவாங்க. That means what? Once I have loaded the count value to the timer, I can independently do any work. The timing நான் calculate பண்ண தேவையில்லை. Whereas in the case of software, the CPU is executing the delay program. That means it is engaged in the particular operation. Fine. Is it clear to everyone what I am speaking? When I am going for hardware timer, I can generate the accurate timing as well as I can relieve the CPU. Yes? Is it clear? Yes or no? See, the timer use பண்றதோட advantage என்ன நான் சொல்றேன். ஒன்னு accurate-ஆன டைமிங் கிடைக்கும். இன்னொரு விஷயம் most important thing என்ன? Count value கொடுத்துட்டு நான் பாட்டுக்கு என் வேலையை பண்ணிட்டே இருக்கேன். As a CPU, I can execute the program. Main programல போய் நான் ரன் பண்ணிட்டே இருக்கேன். டைம் முடிஞ்சிருச்சுன்னா எனக்கு interrupt generate ஆயிடுமா? Interrupt generate ஆனா என்ன பண்ணணும்? Okay, டைம் முடிஞ்சது. இப்போ என்ன வேலை அதுக்காக பண்ணணும்? பண்ணி முடிச்சுட்டு again I can do the regular routine so that the CPU can be relieved from counting the timing. Yes. So that's all about the thing. Fine. Now we'll go with an example. Find the count value to be loaded into the timer bar counter of 8051. Okay. Operated in mode 1 to generate an interrupt after 100 count. 100 count க்கு அப்புறம் எனக்கு interrupt generate ஆகணும். Mode 1 ல operate ஆகும். This is the key point. What about the formula? Desired count. First we have to know. Fine. Desired count எவ்வளோ? 100. 100 count is my desired count. Fine. So this I am representing in hexadecimal. Fine. What about the count value to be loaded? அதுக்கு முன்னாடி maximum count என்ன? FFFH. How it is FFFH? Here I told mode 1 operation. That's very, very important. Mode 1 operation meaning என்ன? Maximum count வந்து FFF as it is a 16-bit timer bar counter. Correct? Mode 2 சொன்னா 8-bit. Mode 1 ன்னு சொன்னா 16-bit. Mode 0 சொன்னா 13-bit. Is it clear to everyone? Okay, coming to the point. இப்ப எனக்கு count to be loaded அப்படின்னா என்ன சொன்னோம்? Maximum count value minus desired count value plus 1. பண்ணா என்ன கிடைக்குது பாருங்க? FF minus 0064 plus 1. So we will be going to have f of 9b plus 1, f of 9c. In the particular count value, TL0 la enna load pannuven. What I have to load in TL0 now? Lower byte la enna load pannuvom? THX, TLX. ரெண்டு ரெஜிஸ்டர் சொன்னோம் கரெக்டா? TLX ல எதை லோட் பண்ணுவீங்க? 9C. THX ல எதை லோட் பண்ணுவீங்க? What we will be loading in TF? THX la very good, FF. See, lower byte always loaded in lower byte register, higher byte must be loaded in higher byte register. Now 9C la irundhu 9D, E, F, aprom A0, A1 goes on, FF varum correcta. On 100th count automatically enna aidum? Overflow occur. So this is the way to load the count value. Is it clear to everyone? Is this thing is clear to everyone? Yes? Yes, fine. Now, as the timer of 8051 takes one mission cycle, 12 clock pulse per increment in count. The counting rate is FOSC by 12. இதெல்லாம் நமக்கு தெரிஞ்சதா. Hence, time taken for an increment is given by 12 by FOSC. Frequency of operation divided by 12 na time taken enna agum? 12 by FOSC. Fine. The desired count value to generate the required time using timer can be calculated as follows. For example, timer அப்படினு சொன்னா நான் என்ன பண்ணனும்? I have to find the count value which is going to be generate the required time. alla கவனிக்கணும். நான் இங்க டைமிங் ஜெனரேட் பண்ணனாலும் கவுண்டிங் தான் நடக்க போகுது. Fine. What I am going to count? Internal clock pulse தான் கவுண்ட் பண்ண போறேன். Fine. Here how you can find the count value for attain the desired time delay generation. அதுதான் பார்க்கணும். Fine. Here we have one formula. Desired count is equal to required count divided by time period of one machine cycle. This is very very important. Fine. இது ஏன் இந்த formula அப்படினு பார்த்தோம்னா ஒரு count அப்படினா மீனிங் என்ன? That is the time period of one machine cycle. அப்ப எனக்கு required time வேணும் அப்படினா மீனிங் என்ன? Required time divided by number of machine cycle போட்டோம்னா fine. Sorry, time period of one machine cycle போட்டோம்னா how much time the count has to be happen அந்த வேல்யூ கிடைச்சிரும். Fine. Okay, now we'll go with an example. The slide is screenshot எடுத்துக்கோங்க. We will go with an example. With that, we will stop today's session. And the example oda stop பண்ணலாம். Example. Find the count value to be loaded into the timer of 8051 microcontroller configured in mode 2 to generate 100 microsecond time. Fine. Assume FOSC is equal to 12 megahertz. Can we solve the problem? Can we find the count value for this problem? Yes? Yes, fine. First thing, required timing 100 microsecond, operating frequency 12 megahertz. What about the desired count? So time period of one machine cycle kandupidichachi 1 microsecond. Time period of one machine cycle equal to 1 microsecond, which is calculated by reciprocal of FOSC by 12. Fine. Desired count is equal to required count divided by required time divided by time period of one machine cycle. What about the required time? What about the required time? 100 microsecond. Fine. What about the time period of one machine cycle? 1 microsecond. That means 100 microsecond divided by 1 microsecond, which is going to be 100 count. Fine. So this is the desired count. What I have to calculate? What count value I have to load? That I have to calculate. In the screen la screenshot eduthukonga. Kindly take this slides as a screenshot. Okay, fine. So now already we know how to find the count value to be loaded. What is the formula for that? Maximum count minus desired count plus 1. Correct? Yes or no? Yes or no? Yes. What about the maximum count in this given problem? It is operating in mode 2. What about the maximum count? Mode 2 na 8-bit timer with auto reload. Yes, very good. So how I have to find the desired count value? 64 hexadecimal la convert paniyachi. Maximum value FF. The reason is it is configured in mode 2. So count value to be loaded is equal to FF minus 64 plus 1. So which is going to be 9B plus 1. So 9C is the correct answer. Is it clear to everyone? Is it clear to everyone? So this is the way you have to find the count value. Counter operation irunda இதுக்கு முன்னாடி பண்ண மாதிரி பண்ணிக்கணும். டைமர் ஆப்ரேஷனால என்ன பண்ணிக்கணும், desired count கண்டுபிடிக்கணும். Then you have to go for the count value to be loaded. That's all about today's session. Okay, I will stop the recording.